Hi, here's Professor Verkler, and today we are going to talk about potentiometers, which are adjustable resistors. So this is what the package of an actual potentiometer looks like, right here. Notice it has 3 wires, and then this knob here that you can rotate. So what's going on inside this potentiometer is there's a long piece of resistive material here in red. And what we have is there's a little wiper right here that touches in the middle of that resistive material. Now, back when we learned about resistance, we learned that the longer a piece of conductive material was, the more resistance it had. And so the same principle applies here. So by touching a contact in the middle here, we're breaking that long piece of resistive material in half and creating 2 smaller resistances. So that means between this and this wire, we have a fixed resistance. And then between these 2 wires and between these 2 wires, the resistance is variable, and it depends on where this wiper is rotated to and where it touches on the resistive material. So when we have less resistive material over here, for example, we have smaller resistance. And when we rotate it this way, so that we're touching over here, then this left side has this much resistive material, so it has more resistance. And then these 2 resistances will sum up to the total fixed resistance. So that is how we create a variable resistor. And these are used in a lot of different electronic devices. Your stereo might be a classic example that there's probably a potentiometer under this knob. And as you rotate the knob for the volume, that will change the resistance. And then the circuit turns that change in resistance into a change in voltage, which it can read and know that you're asking for the stereo to be turned up. So big picture, we can think of a potentiometer as turning rotational motion into an electric signal. So this is the symbol we normally use in circuit schematics for a potentiometer. Notice it has 3 wires leading into it, just like there were 3 wires on the potentiometer. And the potentiometers in your kit look like this, and this is like another one that's very similar. So notice these ones just have kind of little holes here where you can fit in a screwdriver head to turn them. They don't have like a handle sticking out you can turn. And so when you attach to this, you want to always make sure if you're trying to get a variable resistance, you want to always make sure that one of the wires is attached to the movable wiper, since the total resistance is fixed. And so that movable wiper will be the 3rd leg here, or in that case, it's the middle leg. So if I flip this over, the legs are like this. So this middle leg is the one I would want to make sure one of my wires is attached to for getting a variable resistance. And then you can use either of the other 2 legs since resistance is symmetric. So to attach that middle leg, I'd have to put a wire somewhere in these holes in that row. So another way to think about a potentiometer is that it's just a built-in voltage divider. So the total resistance in this case for the voltage divider equation is 10 kiloohms, right? Because V is equal to V total times by R measured over R total. So in this case, 10 kiloohms is R total. And then whatever fraction of the resistance is here would be what is on top. And then V tot in this case is 9 volts. And V right here, that's the voltmeter attached to measure. So let's talk about that again. Over here is an example of how we connect up a potentiometer in a voltage divider configuration. So the battery is attached to those outer two wires on the potentiometer. And then your multimeter is attached to the same row as these two to measure the voltage. And so we'd said the whole resistance is 10 kiloohms. And then as we rotate the wiper around, that will change what this R1 is. And then this one will always be the other fraction of the 10 kiloohms. So 10 kiloohms minus this resistance. So a voltage divider, according to the voltage divider equation, V out must be equal to 10 kiloohms minus R1 in this case, over 10 kiloohms multiplied by the 9 volts. And then some examples of this would be, I have a knob here, right, I'm turning. I can turn it all the way to the left. I can turn it all the way to the right. So if I turn it all the way to the left, let's say, then maybe that will make this right here 0 ohms and this one 10 kiloohms. And so in that case, to the left, I have V out should be 0 over 10 kiloohms multiplied by 9 volts, which is 0 volts. And then I can turn in the other extreme, let's do a different color, the wiper all the way to the right here. In that case, all 10 kiloohms will be on this bottom one, 0 ohms will be on the top. And so then for the voltage divider equation, I'm going to get V out is equal to 10 kiloohms over 10 kiloohms times 9 volts, which is equal to 9 volts. And then let's imagine for the last case, we turn the screw just to the middle. So that means we're right in the middle here. We have two equal sized resistors on either side of that movable wiper. So we have 5 kiloohms and 5 kiloohms. So then we have V out is equal to 5 kiloohms over 10 kiloohms times 9 volts, which is equal to 4.5 volts. So you can see here that the voltage is directly tracking the resistance in this voltage divider. And so as we move that wiper and change the fraction of resistance that's on one side of the wiper, we change the voltage out. And now we have a voltage that our circuit can read and see that there's been a change in the position of that potentiometer.